welcome to the Journey Chez Chem. Well, please do the 2 warm-up questions to the best of your ability, and we'll discuss them in a moment. Number 2, we are using an equation that we derived from the original equation that the change in the temperature of the boiling point is equal to the molality times the constant, the boiling point elevation constant, times the number of particles. And we went through how that was derived. Well, now I am using the equation that we derived to determine the molecular weight, or more technically, the molecular mass of a compound. Now, whenever we have these problems, they are always for non-electrolytes, non-dissociating and non-ionizing. And that makes it very simple. We don't have to worry about the number of particles here when we put the numbers into this formula. And it's very straightforward, actually. We are given the grams of solute as 16 grams. And we have to, however, look up the values for benzene because the constant and the change in temperature depends on my solvent. And I had benzene here. And therefore, my constant, my boiling point elevation constant, is 2.53 degrees Celsius per mole. And then my kilograms of solvent, I am given 225 grams, which I must change to kilograms. And we've done lots of conversions. And this number then would be 0.225 kilograms. And then I am given the amount that the boiling point went up, and it is 8.25 degrees Celsius. And when I do the math here, I get 21.8074. Now, molecular weights, the numbers that we take off of the periodic chart, we know that we must take them to the tens place. We round them to the tens place. We've been doing that all year, so we're very familiar with that. Well, the 0 does not round the 8 up, and therefore it is 21.8 grams per mole. Now that's the answer to number 2, but I want to go through and show you how we get grams per mole. Because oftentimes students ask, well, that grams, there's no moles in here. But actually there are moles. And if we look at this, we see that we have grams times degrees Celsius per molal. Well, molality is moles per kilogram. And then we're dividing it by kilogram and degrees Celsius. And when you look here, you see that my degrees Celsius cancel and my kilograms cancel, and I'm left with grams per mole. Isn't that interesting? I knew you'd like to see that, so I wanted to make sure that you understood how very important it is to follow through on units. They always make sense and they always come out. And that's how we determine the molecular weight of this compound. Now, I want to mention a couple of things to you about the lab that we had yesterday. And I believe I did mention this once before, but I want to drive it home. We were measuring the density and we are comparing it to the boiling points. Well, it's the density of the solution. And remember, there's a solubility issue that goes on here. A lot more of the sodium acetate can be dissolved in the solution because it is much more soluble. And the calcium hydroxide is not very soluble at all. And it looks cloudy. It looks like it's very soluble, like there's just a lot of it in there, and there isn't. So that's very deceiving. And its solubility is much, much less. I just wanted to reiterate that for you because it's a very important factor in the lab that we did yesterday. And we had so much fun, didn't we? Well, that's all I have for you today, and I'm sure you're going over these problems so that we're getting prepared to go forward towards the assessment, and then we'll just have one topic left. Well, I can't wait for that, and I can't wait to see you tomorrow. Bye.